Welcome to College Algebra. We're starting here in Chapter 1, and we're going to have a good time this semester. We're going to start off with something probably pretty simple, but that's the way to start. Linear equations. Some basic terminology. We always have to know how we're speaking, what phrases we use, what words we use. So identities, well, let's get started. We'll get to all that. First of all, an equation, and yep, there we go. Statement, two expressions are equal. In other words, if we look down here, this is an expression, that's an expression, and we're saying that they're equal. There's an expression, and they're equal. And last of all, got a trinomial there, and the zero there, and they're equal. If you want to solve an equation, that means you're going to find the numbers that make that equation true. And those solutions are called solutions or sometimes roots. Sometimes they're called zeros too, but we'll get to that in time. If you put all those numbers that do happen to be solutions together and talk about set notation, the group of all of those put together is a solution set. And the equations with the same solution set are equivalent equations. In other words, you've got equation number 1. Let's see, there we go. Equation number 1 here, and equation number 2 here. If those have the same solution set, then they're equivalent equations. Next, this you've definitely heard of before. A, B, and C are going to represent real numbers, anything from the number line. And this just says that if you have A equal B, whatever A is, whatever B is, some expressions, then if you add the same number to both sides, you still got an equivalent equation. So if you have x plus 2 equals 9, and we add 6 to both sides, x plus 2, and we'll add 6 over here, then 9. If we add 6 on the other side, it's still equal. No problem. Add the same number to both sides of an equation. Or, as long as you don't use 0, you could also multiply the same number on both sides. And you'd still have an equivalent equation, or one that has the same solution set. So if you had 3x equals 5, you could take 3x times 7 and 5 times 7. This is supposed to be a 5, and it would still be equal because we've multiplied both sides by the same non-zero number. Next, this is what a linear equation in one variable looks like. This is an example with just A's and B's used. For example, if we put a regular number where A is, say 4x plus, let's say 19 equals 0, that's a linear equation in one variable. The one variable is the x. And the linear equation is called a first degree equation because the greatest degree of the variable, in other words, the x, the number up here, the greatest degree is a 1. If it's anything else, it's not a first degree equation. So here are some examples of linear equations. Notice here, it's x to the first. It's the only x. All we're concerned about is the x's. Here we have x to the first, x to the first, x to the first, no other exponents on the variable except 1's. So those are linear equations or first degree equations. Now, an example of some that are not. The square root of x, as we'll get back to at some point, you could write that as x to the 1/2 power. And since this is not a 1, it's not a first degree equation. Over here, this looks like it could be because that's next to the 1, but it's in the denominator. Another way of, or an equivalent way of writing that is x to the -1 equals -8. This is not a 1, so it's not a linear equation. And last of all, this one is not a linear equation because x has a 2 as an exponent. So it's a non-linear equation. Next, let's try solving one. So here's an equation for us to play with. And first thing we do is we copy it nicely. And then the first thing that comes up is we need to do some multiplication or simplification. So we'll multiply 3 times the 2x, that's 6x. 3 times the -4, that's a -12. And on the other side, 7 is just 7. And the minus in front of the parentheses means we're going to change the sign of everything inside. So this positive x becomes a -x, and the positive 5 becomes a -5. There we go. Now, next thing we want to do is we want to do some simplification. On the right-hand side, we have a 7 and a -5. We can combine those. So 6x minus 12, we'll leave that alone for the time being. And we'll put the x first, at least that's the way I like to do it, minus x. And 7 minus 5 is 2. We're getting a little bit closer. The next thing we want to do is get all the x's on one side. Well, we could do it either way. My preference typically is collect the x's on the left side. To do that, I need to get rid of this number right here. Get rid of it. To do that, we're going to add x to both sides. What do I get? 6x minus 12 plus x, 7x minus 12. And on the other side, these x's give us 0. 0 plus 2 is 2. Now that we've got all the x's on one side, we need to get the numbers on the opposite side. So to get rid of this -12, we'll add 12. So add 12 here, add 12 here. We know that that's going to give us an equivalent equation, or one that has the same solution set. So 7x minus 12 plus 12, these 12's give us 0. 7x plus 0 is just 7x. Looking good. And 2 plus 12, 14 of course. And we're almost finished. We need to find out what x is. Because up here, we're saying this about x. We want to find out what that x is. Well, one more step. We'll take that 7x, divide it by 7. That'll give us x. Do the same thing to both sides. So these 7's will cancel, giving us 1's. So we'll have x on the left side, and 14 divided by 7. Remember, the fraction bar means divide. So x equals 2. If we want to write it as a solution set, we can write it like this with braces. Brace on the left, a 2, and a brace on the right. There's our solution set. Sometimes you'll need to give this as your answer. Sometimes you'll need to give this as your answer. It'll all depend what the question says. If it says just solve, either one of those will be sufficient. That's the PowerPoint just going through the steps. You can go to the original PowerPoint if you like. We've got that on Blackboard. And you can go through this yourself and practice a little bit without my help. Follow their steps, follow the steps that are on this video. Either way, you'll be in fine shape. So here's the check. Here's where you take that. Remember, we found x equals 2. So we'll take that 2 and put it in for this x. And we'll put it in for this x and make sure it says something perfectly true. Always check, just in case you made a simple mistake, or a complicated mistake for that matter. A little bit of a mistake here. This should be times, and everything else should be okay. So put a 2 in where the x's were, like here and here. Simplify a little bit, simplify further, and we know this is true, so this whole thing checks out. X does equal to 2. It's a conditional equation, and we'll get back to that too. Next, we're going to take a look at the one that has a fraction. Oh no, I know. You're saying, how did I ever get into this? I thought I left fractions behind in high school, or elementary school even. Well, not quite. Well, the first thing you need to do when you see an equation that has fractions in it, find the least common denominator of all the denominators. Oops. So we want the least common denominator of 3, 2, and 4. Those are our denominators. What's the smallest number that all three of those divide into? 12 is the smallest number that all three of those divide into. Now, here's a real trick. Multiply the equation by the lowest common denominator. Fantastic things happen when you do that. So let's take a look at this. We're going to multiply 12 times the first term, which is this one up here, 2x plus 4 over 3, and then we'll multiply 12 times the 1/2 x. On the other side, 12 times 1/4 x, and 12 times 7 over 3. All right, looks like it's worse than it was before. Let me real fast change the color on those. I'm going to change the color to blue, because what I want to do next is, after I multiply by that least common denominator, I'm going to do some canceling. So this is 12 over 1. Oops. Yeah. 12 over 1. So 3 into this is 1. 3 into this is 4. Let's go through all these, and we'll come back and simplify. 2 into this is 6. 2 into this is a 1. 4 into this is 3. 4 into this is a 1. 3 into this is 4. 3 into this is 1. Take note that now all the denominators are 1. So when we multiply through, we won't have any denominators at all. That means no fractions. Fractions? Nope. Now let me switch back to red again so I can be consistent. And let's see what we've got. Over here, if we look at this part right here, I have 4 times 2x plus 4. Think of this as a quantity. 4 times 2x is 8x. 4 times 4 is 16. Next part, I'm going to separate these artificially. We've got 6 times x. So 6x, looking better, isn't it? Equals, on the other side, I've just got 3 times x, 3x, and 4 times 7. Remember, we've got a minus here, minus 28. All right, let's get back to business here. We'll combine the two x's on the left-hand side. 8x, 6x gives us 14x. We've still got the 16. Can't add that because they're not similar terms. On the other side, we'll just copy this 3x minus 28. Next, you know the deal. We'll subtract 3x from both sides. What do we have now? 11x plus 16 equals 3. The x's are gone over here. We'll have minus 28. Now we need to get rid of the 16. So we'll subtract 16, which means, remember, do it to both sides. That way you get equivalent equations. On the left side, you're left with 11x. On the right side, a negative 44. And last of all, if we want to cancel out this 11, we'll have 11x over 11 and minus 44 over 11. And what do we get? X equals a negative 4. So you can give this as your answer if it just says solve. If it says find the solution set, then you'll write it like this. Okay? That's a big hint. That least common denominator and multiplying through by that eliminates all of those fractions. That way you can work as you normally would like to do in solving equations. Next, you can go through this if you like, one step at a time. And there we go, just like we did. And don't forget, you need to check. If you don't check, you're opening yourself up for an error, because it has to work in the original equation where the solution is put in for the x's. If it doesn't, then you'd better go back and start over. You made a mistake somewhere. And we've got it. Moving on. What's an identity? It means that what's on the left side is the same as what's on the right side. Notice if we multiply the 3 times this x plus 1, that's what we would get. No matter what x we put in, it's always going to be true. So that's why it's called an identity. You can use any x whatsoever. If you talked about a solution set, for example, your solution set would be all real numbers. If it works for some numbers but not others, then it's a conditional equation. In other words, there's a condition on this equation. It works sometimes, it's true sometimes it's not, depending on which x you choose or which number you choose to use for x. And last of all, we had an identity, we have a conditional equation, and we've got one that has no solution. It's called a contradiction. Like this one here. That should be pretty obvious, I think, because if you took this equation and tried to solve it, look what happens. Subtract x from both sides, and what do you get? 0 equals 1. Obviously not ever true. That's why you have a contradiction, and that means it has no solution. That's the third type of equation. Remember, 3 types: identity, conditional, contradiction. So let's take a look at this and see what we've got here. So we've copied the equation that we're interested in. The first thing we need to do is do some simplification. We'll use the distributive property to multiply through this. So negative 2 times x is minus 2x. Negative 2 times 4 is negative 8. And then we'll copy the rest because nothing else needs done right now. The next thing to do is combine these x's on the left side. That'll give us a minus x minus 8 equals x minus 8. Oops, that's a positive x. And x minus 8 equals x minus 8. That's an identity. It's always true. So this original equation up here, no matter what number we put in for x, you can even put in 3,572. Or you can put in 63. Anything you like, and it's always going to be true. All real numbers. A shorthand way of writing that, the way I like to do it, is just make a fancy R for a set of real numbers. Next, what kind do we have here? Well, here's our 5x minus 4 equals 11. We'll add 4 to both sides. That'll give us 5x equals 15. Divide by 5. X equals 3. By the way, stop for a moment and notice what I've been doing. I write down the steps. I show what I'm doing. Why is that important? First of all, it gets you in the habit of doing the right things at the right time. Second of all, suppose this were in a test and you saw 5x minus 4 equals 11. What if somewhere in here you make a silly mistake? You add a 1 to the left side and a 3 to the right side. If when I'm correcting your paper I see that you made a silly mistake, then you'll probably get a lot of credit for that particular question. So show your work. It also is good practice because when you get to something that's more difficult, you're in the habit of doing the right things at the right time. So that's a conditional equation. It's only true when x equals 3. Next, how about this one? Here we've copied the equation and we'll simplify this left side of 9x minus 3 equals 9x plus 7. Now we'll subtract 9x from both sides. Where does that give us? Where does that take us? On the left side we'll have negative 3. On the right side we'll have a 7. That's suspicious, isn't it? Negative 3 and 7 are not the same. Ever. That means the solution set would be the empty set. Or, depending on how the question is stated, you might say there's no solution. No number anywhere will make this equation a true statement. So there's a summary of all three of those. Identities, when it's true for all numbers. Conditional, when it's true for some. And contradiction, when it's never true. Moving along. A formula is a linear equation. And it's an equation for a particular purpose usually. For example, simple interest. We've got a formula for that. Here's one you ought to write down. This is the variable for the interest, as it says. Remember that. Now this says P is the variable for dollars. Well, why is it called P? Well, there is a reason. this represents the principal that you put into your bank account to get the interest out. The rate is the variable for the annual interest rate, and you write that down. If you get 4%, for example, you're going to make R equals 0.04. Make that into a decimal or a fraction, but usually a decimal, to work this out. The third thing is T is in years. Don't be tricked. It has to be in years. If your question says T equals 5 months, then that's not what you want to use up here for T. You would have to write T equals 5/12 because you need it in years. Special note. Make sure it's in years. If it's not, change it to years. If it says 120 days, then T equals 120 over 365. That's how many years. If you want to isolate one on one side, here's our original formula again. You want T on one side. That means the PR you don't want there. Now I'm going to write it a little bit differently. Since we want T, I'm going to write the part that has T on the left side. You don't have to do this. I'm just doing this so it looks a little bit different in case that's your preference. Now, to solve for T, I'm going to have to get rid of the P and the R. And the way I can do that is take that PRT, divide it by P, also divide it by R. That will leave me with T on the left side. But remember, what you do on one side, you do the same to the other side. So it'll be I interest over P R. Final answer, the P is canceled, the R is canceled to all cancel to ones, and your answer will be T equals I over P R. And there you go. Next, this formula gives you the future value, the one coming up. It's future value or maturity value. So imagine this. You take a bag of money to the bank. We're going to put a tie in here so it doesn't fall out. And you're going to come back at some future time where that money has matured. How much money is it? Well, that amount is called A. So you might see it as amount. You might see it represented as future value in the wording, or maturity value. P is the dollars invested. Remember, that's principal, and remember that's the PAL at the end. And T, remember, the T always has to be in years, so switch it to years. And we're talking about simple interest. We'll get to compound interest in due time, but not right away. That'll take a couple months, or at least a month anyway. So there's our formula. That will give us the amount at some point in the future. If we invest P dollars, that's the principal, at this annual rate R, write that as a decimal, and T, remember that's going to be in years. This is an example of a place where you'd want to use the calculator. You should be good with your calculator by this point, because I gave you that calculator worksheet to double check and see if you know how to use your own calculator, because we're going to do some interesting calculations. Next, so we want to solve for P. Well, that's similar to what we did before, but a little bit different too. That's why we have this one. So first thing we're going to do, we want to solve for p. So all the p variables need to be on one side. Well, since this is a positive PRT, we'll just add a p to this side and add a p to that side. Okay, what do we have now? What I've got now is a on the left side because p has disappeared. And on the right side, I've got PRT plus p. And if you want to, you might want to write it this way. It doesn't matter. And you want to isolate the p. Well, how do you do that? Well, we're getting there. The first thing you have to do is get all p's to one side. We've got that. And then there's a little trick that you have to do sometimes with solving for a variable. Both of these have p. Well, we can reverse distribute the p and make this p times 1 plus RT. Notice multiplying this out again. We've got this back, and eventually we can get back to where we started. Now we want to solve for p. Well, what's in the way? I've got 1 plus RT multiplied times it. So if I divide by 1 plus RT on the right, I'll have to do the same thing on the left. Divide by 1 plus RT. Over here, these 1 plus RTs will cancel, and we'll get a P. And that's what we wanted to solve for. Make that P look a little better. And on the left side, A on the top, and on the bottom with 1 plus RT. Remember, amount is the future value or the maturity value. R is the annual rate of interest, and T is the time in years, and P is the principal. Okay, let's solve for X on this one. We want to solve for a specified variable. Notice, if you look through this, there's an X, there's an A, and there's a B. This doesn't look too good, does it? Well, if you remember that all of these variables, the X, the A, and the B, are just numbers, that will allow you to get through the whole problem. So, first of all, remember we want to end up with X on one side. So the first thing we're going to do is distribute that 3 across the parentheses. So we'll have 6x minus 15a and 4b plus 4b equals 4x minus 2. All right, that's a good start. Now I want all the x's on one side, so I'm going to subtract 4x, subtract 4x. So right now what we've got is 2x minus 15a plus 4b equals negative 2. I want all the x's by themselves. So this term and this term must go. So if I add 15a to both sides, I'll still have the 2x. This one will disappear. And on the right side, I'll have minus 2 plus 15a. But I also want to get rid of the 4b. So I'm going to have to subtract 4b. Subtracting 4b, and I only have 2x on the left side, and now I have minus 4b on the right side. And we're getting close. I need to divide by 2. Remember, don't worry about the a's and the b's. Just treat them as you would solving an equation. Just ignore them. So I'm going to divide by 2. Divide by 2 just as I normally would. So on the left side I'll have x. Hooray! Yes. On the right side, what do I have though? Okay, on the right side I've got, and that you can leave it the way it is actually, or you might want to write the letters first, the variables first. 15a minus 4b minus 2 over 2. And there's your answer. There we go. Notice that's what they did too. They put the 15a and the minus 4b before the minus 2. That's typical. You don't have to, but it is typical. So if you're comparing answers with someone else, because you're working together, if you both write it like this, it'll be easy to compare. That's all it is. All right, we've got something to work on here. So let's pretend this is real life. The woman borrowed $5,240 for new furniture. She'll pay it back in 11 months at an annual simple interest. I'm not getting complicated. So, remember the formula for that is I equals PRT. I would suggest you might want to memorize that, but at the very least you want to write it down in a special place where you can keep all your special formulas. That's really helpful. Now you want the interest, so this is really set up for you. So I equals, and we'll just put the numbers in. P, what's that? That's the principal. That's how much money we started with. $5,240. You can put the dollars in if you like. Just remember that at the end if you don't. R. Now R is in a percent up here, and it's the annual. That's good because R needs to be the annual one, but we need to change this to a decimal. So 4.5%. If I want to change it, I'll move the decimal point 2 places because the percent, so our annual rate as a decimal looks like this. And the time. This is a good place to remember that time needs to be in years. So right now we've got T equals 11 months. How many years is that? Well, T equals 11 twelfths of a year. Now we're ready. Put in 11 twelfths, and all that's left is to pull out your calculator, because I assume that you don't want to do this in your head. You don't want to do this on paper. And we do have calculators, as long as you use them for the right things. So here, notice, we've got the interest as a decimal, principal. We leave out the dollar sign, but you could put it in if you want to. That way, when you get to the end, you know you've got the interest in dollars. Either way, remember what you expect to get for an answer. So putting those together, there are your numbers, and we've got $216.15. Now, a word of caution. I would say warning, but it's really caution. The interest is in dollars. If you only put 216.15, that's not correct for the interest. Because if you just put that, then someone who reads it won't know whether it's euros, pesos, or what it is. The dollar sign is important, and you can be sure of one thing. If you don't have this in your answer, you're not going to get full credit. Okay? All right. And there we go. So we can review here. We learned some basic terminology. We learned what linear equations were. We talked about identities versus conditional equations and contradictions. And also how to solve for a specified variable. And those are called literal equations because they have a bunch of letters. Not all numbers. And that's it. We'll see you next time in section 1.2, where we'll take this a little bit further. You take care of yourself, and we'll see you either in the next class or in my office if you have some questions. See you then.